Mark said, I went to the HTML5 Developers Conference here in San Francisco last week, and with this presentation, my goal is just to teach everybody some different aspects of HTML5 and talk a little bit about high-performance HTML5 geared towards speeding up websites, and then show you a practical example of how we're using it at Tagged already. So, things I'm going to cover: what is it? What is HTML5? And then I'm going to go over the different feature areas as specified by the W3. Talk a little bit about high-performance HTML5 and give you an offline storage example. So the first thing, what is HTML5? It's the newest version of the spec. It's not finalized, and it probably won't be for quite some time. Some people say 2020, as late as 2022. But most of the features, like a good chunk of the features, is supported by the major browser vendors today, so we can use a lot of it. It's focused around the creation of web applications, so delivering users experiences that used to only be possible on a desktop app written right in the browser. And for me, it's sort of a return to a sense of solidarity in building for the web, because you can do with HTML5 a lot of what you used to have to do with JavaScript. And also, like, you can do a lot with CSS3, which is sort of included in the HTML5 spec, that you used to only be able to do with images. So feature areas, these are the 8 different feature areas that the W3 specifies. And I'm just going to go through each one of them, talk a little bit about why they're included and what technology sort of embodies each feature within the spec. So first up is connectivity. And HTML5's offering in terms of connectivity is through technology called WebSockets. What WebSockets do is they provide like a low latency bidirectional channel for communication between browsers and servers. So you can pass data to a user whenever new data is available, rather than the user taking action to go and grab some data. So applications for this are the obvious sort of chat, multiplayer games, anything that monitors, maybe like a stock price monitoring application, anything like that that just needs to infrequently push data to users. WebSockets is going to be a good way to do that. Next up, device access. Device access includes things that access features of the phone, the laptop, the computer, the television, whatever the application is being run on. So this includes geolocation APIs, accelerometer support, and then video input, but one of my favorites, speech input. If you guys use Chrome, you might have seen this on Google already. But there's this feature where you can basically dictate to the input, and I'm going to turn the mic off because it might interfere with it, but I'm going to give it a try. So, tagged rocks. Oh, I grabbed the first thing I said. Let's try it again. Everybody be quiet. Tagged rocks. Well, whatever. I mean, as with any kind of technology like that, when you try to do a live demo of it, it's not going to work very well. But in the kind of like everything disclosed, like you add this to this attribute to an input, and then it makes a request to one of Google's servers to do the matching, and it just uses the same thing that it does for Google Translate. So, yeah, moving on after that failed demo. So the next thing is styling, and when you talk about styling in the HTML5 spec, you're really talking about CSS3. Some of the features that it offers are like animations, translations all around the screen, rotations, and then even transformations and transforms over specific periods of time for properties like opacity, position, background position, and whatnot. But sort of more practically and really usefully, they offer gradients and opacity. So whereas you used to have to use an image to just do a simple kind of linear gradient on a header div or something like that, you can just do it with CSS now, and that cuts out the need for an extra request for an image. So if you do that all over a site, you can tremendously cut down on the amount of requests that you're making. You're requesting those CSS files anyway, so you might as well just do it there. And it's totally possible to do an entire site, like all the navigation elements, all the sort of appearance of the page in just CSS. Somebody rewrote the Dig v3 UI using all CSS, and then the only images on the page were like user-submitted images. So if you can imagine on the amount of time that would cut down on, it can be really useful. Semantics are the next feature area, and they added a bunch of elements on the top, and they also removed a bunch. Most of the elements that they added have to do with sort of typical positioning elements, header, article, which sort of takes the place of where everybody used paragraphs before for item after item when they're not really paragraphs. It just can be articles of anything. And then the W3 actually did something really smart when they went to go make new elements, in that they crawled the web and they looked for the most commonly used ID and class names on divs. So they go out and see billions of documents, they see hundreds of millions of div class header, and then they're like, well, we'll just make header a new element in the spec. So I thought that was a good way to do it, kind of like them being reacting to what's already popular programming practices anyway. And the stuff they removed, a lot of it has to do with frames, frame set, no frames, and then a lot of the text elements, like your U tag is gone, strike through, font. You can do all that with CSS now. So it's like no need to clutter up the DOM. Multimedia. HTML5 spec on multimedia is centered around mainly audio and video. You can use these simple little tags to just put like a song or a video into your page. And of course you can customize them with your own JavaScript and CSS if you want to, but if you just, this is like the bare minimum for an audio, you can just add it, it'll work fine. And I mean, it's just a really nice, easy, clean way to add music and video to your site. Performance. So performance is an interesting feature area in HTML5, and one that really ties back in with the idea of creating web applications that have a native feel to them. This technology called web workers is going to allow developers basically to have scripts that run processes in the background independent of any UI level scripts, so nothing on your page will be impacted by any of the processing that these do. And they have access to a number of functions. They can do I/O with AJAX requests. They can do a number of other things, and it's just sort of to have, you know, really processing heavy applications running OS level threads to get work done independent of anything on the page. So that's something that's going to be useful, I think, moving forward. Another feature area, 3D effects. This is a canvas animation written a while ago, 2009, and this is sort of faux 3D, because if you've done any work with canvas, you know that you have to specify a context, and the context in most canvas drawing is 2D. So obviously it's using things like shading and perspective to create the illusion of 3D, and something that a lot of canvas, people that do a lot of canvas animation have been clamoring for is a true 3D context, and the W3 is still sort of debating including that in the spec for HTML5. A lot of people want them to, as you can imagine, especially if you work on games. You know, you'd love to see like a 3D canvas standard go into the spec and enable you to create like really dynamic, kind of hardware accelerated graphical experiences in the browser, but it's not there yet. So they're encouraging browsers, like browser vendors, Mozilla, to make their own sort of proprietary ones now. Mozilla hasn't really adopted that yet, but there are people that are trying to make Firefox add-ons with like experimental 3D canvases. I don't really know how it's going though. I think it's still pretty homebrew, like a small number of people at this point. The last performance area, or the feature area I'm going to talk about, is offline storage. Offline storage comes in two varieties in HTML5, the first being application cache, and the second being local storage, I'll talk about in a minute. The first one is application cache, and you specify an application cache file by adding this to the head of every page that you want application cache to work for. And then within this app cache file, you have four components. You have a revision, and then you have these three sections down below. The revision number allows the browser to know whether or not you've updated it, so it knows whether it needs to parse the document looking for changes and change what's in app cache. The first section is cache. You always want these things to be saved. Network's the exact opposite, never save these. You do this for pages basically that would be useless unless you had internet connectivity. And then fallback is where you can specify like a fallback for a particular page or a fallback for all pages. So a good example of this would be like, say you have a newsfeed or a stream page, you could cache those while a user has internet, and then if they come and try to hit the index page when they're on a flight or they're in a tunnel and they've lost connection, they'll get forwarded to like the newsfeed page where you have all the cached results, and they could browse sort of what they missed before they lost connectivity. So that's something that could be useful. Another variety of storage is local storage in HTML5, and this is one that we're actually using here at Tagged already on the mobile site. So this function right here can check to tell you whether or not the browser supports local storage. You can use that to check before you start trying to do any operations with it. But what local storage does is it stores key value pairs of serialized strings. So anything you can serialize into a string, you can store in local storage up to a 5 megabyte limit. So ostensibly you could serialize images into strings and store them, but what it's most commonly being used for now is common JavaScript, common CSS that's needed all over a site or all over a project. And that's what we're doing with it. We're storing some of our JavaScript in there. So these are sort of just accessors. So the syntax is really simple: set, get, remove, clear. And then if you log this out, you can see like what's in the contents of your browser's local storage. It persists rather across clearing your cookies, across like even power cycles on most phones. So it's really useful for storing like static resources. I'm going to change gears now. I'm done with the feature areas and talk a little bit about high performance aspects of HTML5, aspects of the spec that are geared towards making websites faster, and sort of the reasoning behind that. So the first thing I'm going to do is address two studies done by Google and Bing. This first one by Google, they introduced artificial delays to their search results of 200 milliseconds and 400 milliseconds for small subsets of users. And over on the left axis is like daily searches by the users in this group in comparison with controls that didn't have delays. And then this represents, the bottom axis represents 6 weeks. So you can see this is the 200 millisecond delay. That's the 400 millisecond delay. So engagement just goes way down. And then the most interesting thing to me in the study is that after they removed the artificial limits, it took the users in these groups on average 6 weeks to resume their normal levels of searching. So you know, just a tiny little delay can have a profound impact on how people use your site and engage with your site. Bing did a similar study where they introduced delays to searches, showing kind of the same results across a number of different metrics. Distinct queries per user, query refinement, so typing in something, not seeing what you want, and then changing it, and then revenue, clicks anywhere on the site, user satisfaction. And then the last one I think is the most interesting, in that as they introduced delays, the time that the users took to click a result and pick a result after they did a search went up exactly correlation with that. So it's like if your site gets slower, users get slower in interacting with your site. And I think that was something that I just kind of picked up out of that was interesting. The opposite, sort of, so the reward for speeding things up and using like web optimization techniques, Netflix on their static resources, when they introduced gzipping, noticed 50% outbound data improvement. Edmunds added an expires header and removed e-tags, and they had a 34% decrease in annual bandwidth. And I think the most impressive one, Mozilla, after decreasing the page load time by 2.2 seconds, they got 15.4% more downloads of Firefox from that page. So if you think about that, what could that do for us if we did that to our homepage for new user registration? Like the numbers could be tremendous. So what does HTML5 offer in the way of this? Some of it is what we were already talking about, the advanced caching stuff with local storage and app cache, and then using CSS3 instead of images everywhere that you can to cut down on requests. And then two things I'm going to talk about now are attributes you can add to script tags. Async and defer, you can add these to script tags in HTML5, and async makes it so that the script downloads when available throughout the parsing process of the document. Defer makes it download when parsing is finished, but they download and they execute. So regardless of whatever behavior you have in your JavaScript, saying document.ready or whatever, the script executes when you're done downloading it, even if you use these. So something that was missing is the ability to defer the download and then also execute the script on demand some point later. And mobile Gmail, actually, the team at mobile Gmail figured out a way around this that I think is really clever, where they use defer, so they defer the loading of the script, and then they actually wrapped all of the script in comments, and then at some point later they bound to event handlers, they went in and stripped out the comments and then eval the code, like when they want to. So that's really clever and it's a good idea, but at the same point it's like a lot of hoops to jump through to get to functionality that should probably just be supported anyway. So I think that's something that you'll see maybe get like added to these attributes or another attribute added to accomplish this functionality. That'd be something that would be nice. The last thing I'm going to do is talk a little bit about local storage at tagged, how we're already using it on the mobile team. So we have this sort of process that we developed where we're going to implement jQuery mobile on mobile web, and we have these 3 common files that we include first and print them out, tagged this new local storage library in our api.js file. We print those out right away, And then the next thing that we do is we create these resource keys that have like a resource key or cache key for each of the resources we want to store, which will end up being its key in local storage, and then a revision key so that we can update it if we want to. And together those make up the resource key. So when we go to add one of the files that we want to store in local storage, we first check to see if a cookie is set for the resource key, which we do when we store that object in local storage. So if it's not set, it's the user's first visit to the site. So in that case, we do tag.js, and we print the queue of the resource key for that particular object, and we add attributes data cacheable 1 and the resource key to the script tag, and then we render it inline inside that script tag on the page. What happens then is the local storage library parses the document looking for script tags with data cacheable 1. When it sees them, it grabs the code from inside, stores them in local storage, and sets a cookie. So when that cookie is set and the user comes back, they'll get into this part of the conditional where they've got the resource in local storage, in which case we just echo out a script tag onto the page and then rehydrate the script from their local storage, avoiding the need to make a request. And this is a screenshot of it in local storage on Chrome and the developer tools. And so there's a couple edge cases that you have to consider. It's like, what if a user deletes cookies, like clears their cookies, but the resources are still in local storage? In that case, it would be there, but the browser or our PHP wouldn't really know it's there, wouldn't know to reload it. And in that case, it just gets sent inline again, and then it replaces what was there with the same name because we only ever use this part of it. So in that case, like, we can still update if we want to, but it just replaces this so we don't end up with things piling up in local storage, like revision after revision. So it does have to get sent inline again, but if they're messing with like either cookies or local storage, one or the other, like there's not much else we can do other than that. But if the opposite is true, if they keep their cookies and then they delete local storage, which is less common because much fewer people probably know how to delete things in local storage, but there it would look as if the entity should be there, and then when this rehydrate script goes to get it, put it back out on the page, it just wouldn't find it. And we have a check in there now to just reload the page and send the stuff to local storage again and then rehydrate it. We're experimenting with other ideas, like maybe instead of reloading the page, doing an AJAX request for the script and then storing it in local storage and then putting it out to the page. But we are using local storage for jQuery. So we're still working on that, but right now we just reload the page, send it again, and then rehydrate it. So that's just an example of how we're using HTML5 in some capacity at Tagged already to improve performance and offline capability. So that's really all I have. If anybody has comments, questions, grievances, I'd be happy to address them.
Are we doing anything with App Cache?
We're not doing anything with App Cache yet, but we might be with the Windows 7 phone app. So we have as some of you may know, we have a BlackBerry app that sort of is just a wrapper for the mobile website. And then we're doing the same thing with Windows 7 phone, and we haven't launched it yet, but Dawn's been working on it, and we're looking at maybe using App Cache as a fallback for offline as an experiment in the Windows 7 app first. But I think we should. I think we should start utilizing a lot of this stuff.
Do you have an example of when you would use web workers?
Yeah, web workers is something, I've read about it and it seems interesting, but I haven't really seen it practically applied anywhere yet, so I'm not sure. But I think in the spirit of making these application-like experiences that run in the browser, maybe really advanced games, with sometime in the future 3D canvas support and then lots of processing going on, you might use that to really take care of just a lot of the computation behind the scenes of needing to freeze the UI on the browser.
What percentage of our current user base can actually run browsers that support stuff like this?
It varies across HTML5, but like local storage is supported already really well in all the major, like Firefox, Chrome, Opera, and whatnot, many versions back. And on mobile phones, it's even better for most of these features because mobile browsers tend to be more forward-thinking in these things, especially with regard to offline storage, because that's necessary a lot on mobile. So there are some features that are kind of just like pie in the sky right now, but a lot of them have been around and been well supported for a while, like CSS3 gradients and all that kind of stuff has been supported in most browsers for quite some time. So.
What happens if you fill up local storage?
So, oh, sure. So what happens if you fill up local storage? If you fill up local storage, there is a, I didn't put it on the slide for local storage, but there's actually a little method that you can use to check whether or not it's full. And we have one of those. We're not doing anything with it yet because for us, we know that we're never going to fill it up. If you do fill it up, it'll just throw JavaScript errors when you try to store stuff.
So with local storage, is that a 5 megabyte limit per site or for the whole browser?
Browser.
Okay, so other sites could fill up local storage and you could do
Right. Yeah. It's like think of it like cookies.
Okay.
Yeah.
I'm wondering if there would be other sites also trying to store jQuery mobile in local storage and whether it'd be.
Yeah, but I guess it would depend on if they use the same cache keys, because everything's just key value pair.
Right.
So like.
So you'd never know about it.
Right.
You could take advantage of
Yeah.
the fact that other sites.
Right. Well, I guess if you wanted to like check your local storage, you could like log out, window that local storage, and see what people are storing. But. If you wanted to be a jerk about it, you could just clear local storage too. Think I'm done?
So yeah. Thank you, Alex. So I just wanted to follow up on that app cache thing. It just kind of felt like it kind of comes together with like what the browser support is. What's kind of funny is like, you know how IE is always the one that like doesn't support it? Yeah, our Windows app got rejected because we don't support the offline scenario. So they actually like are enforcing us to use HTML5 as a solution for yeah. So our Windows app is basically delayed because of we were like, well, we'll build that sometime later and we don't really have to worry about like people driving into a tunnel while they're. So it's kind of cool that they're actually enforcing it.